Okay, so basically, I want to talk about the what basically are triggers in SQL. So a trigger, as you can see from the slides, is a database object that's attached to a table. In many aspects, it's similar to a stored procedure as we'd see in functional programming. But the main difference really is that a trigger is attached to a table and is only fired. Fired insinuates that it is released or that it is used when an insert, update, or delete SQL command occurs. You can't explicitly invoke triggers. They can only be called as a result of performing the action which you have previously defined or the programmer has previously defined on the table. So there's two main types of triggers. They're classified into two different sections: after triggers and instead of triggers. As mentioned before, yeah. So there's three types of query types. Using SQL, insert, update, and delete. Combining these, essentially, there are six total triggers. That being after insert trigger, after update trigger, after delete trigger, and then contrary, instead of update trigger, instead of insert trigger, instead of delete trigger. So basically, that's an intro to triggers.
So I will be explaining the functionality of instead of triggers in SQL by using MS SQL as my reference. So the main function of a instead of trigger is to override the standard action of a triggering command, which includes insert, update, or delete. The main functionality of an instead of trigger is to be used as a kind of error or value checking on one or more of the columns before they can be updated or new data is inserted or of course deleted. So unlike an after trigger, instead of triggers are supported on both views and tables, whereas after triggers are just supported on tables. Instead of triggers are attached to another trigger command, which are known as data manipulation language operations. So there's three different types. There's instead of insert, instead of update, and instead of delete, which I will explain now. So to illustrate the instead of insert, instead of update, and instead of delete commands, I will be using a type of scenario which is an employee type database, which includes the qualification obtained by the employee. So firstly, we have instead of insert, and we can see the snippet of code to the side, which is used as a type of error handling or invalid input handling, more so, which ensures that the qualification be trying to be input for the employee is of a valid qualification, such as BA, PhD, or one of those. So what it does is it checks that this is valid, and if it's not, it returns a null value, which is raised as an error before allowing it to be inserted into the database. Similarly, with instead of update, we have a piece of code to the side as well. So this essentially does a similar thing to instead of insert. It just ensures that if one is trying to update the value in the table for a given employee, that the qualification being input is a valid format and a valid qualification. So say one wanted to update the value from master's to PhD or something like that. So finally we have instead of delete, which is a slightly different implementation. So the illustration on the right is a little bit different, just to show you that the delete works by not by deleting the values from the table, but by creating a view in which the appropriate rows are flagged for deletion. So as you can see in the view, they have a separate column with a 1 indicating if it's to be deleted, and then these can be deleted from the view in bulk at the end, and that's the way that one works.
I'm going to talk about after triggers. After is specified to create a trigger to be fired after the triggering event occurs. For example, after row triggers are fired every time an affected row in the table is changed. It can be combined with the insert, update, and delete statements. For example, you can have an after update trigger. Multiple after triggers can be created for the same statement on the same table, but the order they are fired in is indeterminate by default. If the order in which the triggers are fired is important, there's a way around this. You combine the triggers into a new trigger that fires them in the order you want when it's fired itself. After triggers can't be specified on a view, but they are valid for events, unlike instead of triggers which are the other way around. There are many events that can cause triggers to fire. Some events can only be used with after triggers, for example, log on, startup, and server error. So here's an example of an after trigger being used to log errors. The trigger is fired by the server error event, and what it does is check to see if the error code refers to the logon error. If so, it does some special processing, otherwise it just logs the error code, and that's it.
One of the websites researched by our group was PL/SQL's User's Guide and Reference. This website hosted numerous informative chapters on PL/SQL. I have chosen to use the chapter on tables to illustrate the effectiveness of the website. Objects of the type table are called PL/SQL tables, which are modeled as but are not the same as database tables. Table is a composite data type which can store collections of data, in comparison to scalar data types which can only store one item of data. Composite data types can be referenced and manipulated as whole objects. By storing data in a table, you can access large amounts of information by treating the primary key and the row of the table as the index and elements of a one-dimensional array. Like an array, a PL/SQL table is an ordered collection of elements of the same type. Each element has a unique index number that determines its position in an ordered collection. By comparing PL/SQL tables to arrays, it makes the concept easier to grasp. It is important to highlight the two main differences between both concepts. Firstly, an array has a predefined upper bound and a predefined lower bound, making its size finite. However, a PL/SQL table has no predefined upper bound and no predefined lower bound, meaning you can change its size. Also, arrays require consecutive indexing, whilst PL/SQL tables do not, allowing you to attribute meaningful indexes to elements, such as ID numbers. After presenting the concept to you in the first section of the webpage, PL/SQL's User's Guide and Reference goes on to explain the fundamentals of creating a table. Defining, declaring, and referencing. There are two main elements to defining table types. First, you define a table type, then you declare PL/SQL tables of that type. You can define table types in the declarative part of any block, subprogram, or package using the syntax outlined below. Type, table type name, where table type name is a type specifier used in subsequent declarations of PL/SQL tables. Is table of data type, open brackets, not null, close brackets. You can add the not null constraint to a table type definition and so prevent the storing of nulls in PL/SQL tables of that type. Index by binary integer. The index by clause must specify data type binary integer. If the element is a record type, every field in the record must have a scalar data type such as char, date, or number. Once you define a table type, you can declare PL/SQL tables of that type, as the following examples show. These examples are taken from the book Create Tables for Employee Salaries. Type sal tab table is defining the salary table. Is table of emp sal employees salaries with the not null constraint, indexed by binary integer. Then to reference elements in a PL/SQL table, you specify an index number using the syntax outlined below, taken from the book. These slides have provided an overview of one of the many useful websites found whilst completing the bookmark exercise.
So I'm going to be talking about variables in PL/SQL, and this bookmark is from plsqltutorial.com, and I chose it because it was a quick, easy to read introduction to variables in PL/SQL with plenty of examples. So variables are a type of placeholder in PL/SQL that stores values that can change throughout the PL/SQL block. So very similar to variables in other programming languages. The syntax for declaring a variable is the variable name and the data type. And then there's an option to initialize the value when it's declared, or to declare it not null, in which case you must initialize the value in the declaration. And then I've just included an example from the website on this slide, where it shows the declare statement and then the declaration of a salary which has the type number, and then the department variable is declared as not null and it's initialized to HR department. So there's two ways to assign values to variables. You can assign them directly to variables, which I discussed in the last slide. And you can also assign values directly from database columns using select into. In this case, you would say select and then the name of the column, and then into and the name of the variable, and you would say from the table name where you want to get the values from, and then there's an optional where condition as well. And then finally, there's two types of variables in PL/SQL, local and global. Local variables are declared in inner blocks and cannot be referenced by outer blocks, and global variables are declared in an outer block and can be referenced by that block and all of its inner blocks.